Now let us look at one more problem. Length of a wire is 4 meters. The area of cross section is 3 into 10 to the power minus 6 meters square. The change in length is 1 millimeter. Young's modulus is 2 into 10 to the power 11 Newton per meter square. So in these conditions, we have to find the energy stored in the wire. So energy stored will be given by average force into delta L, half F delta L. Here force is not given to us, so we have to calculate force. We know Young's modulus is stress by strain, F by A delta L by L. So this becomes FL by A delta L. So force becomes Y A delta L by L. Right, this is the formula for force. Delta L by L is strain. Strain you multiply by Young's modulus, you get stress. Stress you multiply by area, you get force. So this way you can easily remember the formula. Strain into Y equal to stress. Stress into area equal to force. So you got the formula for force. So energy stored. What will be energy stored? Energy stored will be half F into delta L. So what is F? F is here YA delta L. YA delta L by L. So one more delta L is there, so this will get squared. Now we have to put the values. So half. What is the Young's modulus? 2 into 10 to the power 11. Area 3 into 10 to the power minus 6. Delta L 1 millimeter, that is 10 to the power minus 3 meters. So 10 to the power minus 3 squared. Delta L squared, and length is 4 meters. So what do you get? This 2 and 2 cancel out. This 10 to the power 11 is there. Here 10 to the power minus 12 is there. So you get 10 to the power minus 1. Right? And this is 3 by 4. That is 0.75 into 10 to the power minus 1. This will give us 0.075 joules. That's all. Right? So in this question, length of the wire was given as 4 meters. Area of cross section was 3 into 10 to the power minus 6 meters square. The change in length delta L was 1 millimeter. Young's modulus Y was 2 into 10 to the power 11 Newton per meter squared. So we have to find the energy stored. Energy stored is given by half F into delta L. F was not given in the question, that we got from the formula for Young's modulus. Young's modulus is stress by strain. Stress is force upon area. Strain is delta L by L. So we got FL by A delta L. So from here we got force F equal to YA delta L by L. Alternatively, you can think of this as delta L by L is strain. Strain into Y gives us stress. Stress into area gives us force. So we got the force. Then we use that in the formula for half of energy stored, half F into delta L. And we got the answer 0.075 joules. Now let us look at one problem on bulk modulus. A solid sphere is there whose radius is 20 centimeter. We apply a pressure of 10 to the power 6 Newton per meter square on that. The bulk modulus is given as pi by 3 into 10 to the power 11 Newton per meter square. The question is, what is the change in volume? That's all. So what is bulk modulus? Bulk modulus is given by pressure, or the change in pressure, divided by delta V by V. Right? So therefore this becomes PV by delta V. So change in volume, delta V will be equal to PV by B. So what is the pressure? 10 to the power 6. Volume. Volume will be given by 4 by 3 pi r cube. So r cube 0.2 cube. Radius is 0.2 meters. So 0.2 cube. Divided by bulk modulus, which is pi by 3 into 10 to the power 11. So pi will get killed. 3 will get killed. This is 0.8 into 10 to the power minus 3. So we can write like that. So 8 into 10 to the power minus 3. So what I get? 10 to the power 4 into 8, 10 to the power minus 3, so 10 to the power 3, divided by 10 to the power 11. So this will become 32 into 10 to the power 8, right? So we get 0.32 into 10 to the power minus 8. So we have taken minus to this side, so minus 6 meter cube. So that is 0.32 centimeter cube. So this is how we get the change in volume. That's all. Right? This was a simple question on bulk modulus. Radius of the solid sphere was given as 20 centimeter, that is 0.2 meters. The pressure was 10 to the power 6 Newton per meter square. The bulk modulus was pi by 3 into 10 to the power 11 Newton per meter square. We have to find the change in volume. So bulk modulus is P by delta V by V. Okay, if there is a change in pressure, then we write delta P here, otherwise you can write P here. So P divided by delta V by V. So PB by delta V. So delta V became PV by B. Pressure was 10 to the power 6 Newton per meter square. Volume was 4 by 3 pi r cube. So 0.2 cube we get here. And bulk modulus is pi by 3 into 10 to the power 11. So then when we simplify this, we get the answer as 0.32 centimeter cube. We have to find the maximum length of a steel wire that can hang without breaking. So length we have to find out. The maximum stress that this steel wire can handle is 8 into 10 to the power 8 Newton per meter square. The density of steel is given as 8 into 10 to the power 3 kg per meter cube. The value of G is 10 meter per second square. So you want to find the maximum length of wire that can hang without breaking. So stress is force upon area. Right? Mg by area gives us stress. Mg will be equal to, mass is equal to what? Volume into density, right? So we get V rho G by A. And what is V? V is length into area of cross section. So L A rho G by A cancels. So sigma is L rho G. And once we know that, we can find L as sigma by rho G. So L maximum will be sigma maximum by rho G. Sigma maximum is 8 into 10 to the power 8. Density is 8 into 10 to the power 3. And G is 10. So we get the answer as 10 to the power 4 meters. Right? That's all. Now we'll solve one problem where we look at the change in density due to the increase in pressure. Density of some material is given as 11.4 gram per centimeter cube. We are increasing the pressure by 2 into 10 to the power 8 Newton per meter square. The bulk modulus is given by 8 into 10 to the power 9 Newton per meter square. That is a bulk modulus given to us. So we want to find the new density. New density will be given by rho divided by 1 minus delta P by bulk modulus. This is the formula. So rho is 11.4. The change in pressure is 2 into 10 to the power 8 and bulk modulus is 8 into 10 to the power 9. So if we take now here calculation, this 110 part is extra, so we'll get 110 downstairs and this will become 1 by 40. So this is 1 minus 1 by 40. So 11.4 into 40 by 39. And that will give us the answer 11.69 gram per centimeter cube. So remember the formula for density, change in density due to pressure, the new density due to pressure, rho dash will be rho divided by 1 minus delta P by bulk modulus. Now let us look at one more problem. Length of a wire is 4 meter, its diameter is 0.3 mm. The force applied is 100 newtons, and the change in length is 0.3 mm. They are asking what is the potential energy stored in the wire. So how do you find this? Simple. Potential energy is simply given by half F delta L. That's all. Nothing else is required. So half the force is 100 newtons. And the change in length is 0.3 mm. So 0.3 mm is 0.3 into 10 to the power minus 3 meters. So now this is very easy. So this will become 10 to the power minus 1, 0.03. 0.03 by 2 will give us 0.015 joules. Right? All this data was not required. Length of the wire was given as 4 meters. The diameter was 0.3 mm. The force applied was 100 newtons. And the change in length was 0.3 mm. So potential energy stored is simply half F delta L. Let us look at one problem where area, cross-sectional area is given as 1 millimeter square. Length is 2 meters. The increase in length is 0.1 mm. The Young's modulus is 2 into 10 to the power 11 Newton per meter square. We have to find the work done. So work done for this extension. So work done कैसे मिलेगा? Work done per unit volume is half into stress into strain. इसको volume से multiply करेंगे, then we'll get work done. Right? So this will be the work done for this increase in length. Stress क्या होता है? Y into strain. So this will become half into Y into strain square into volume. Right? So this is the formula. Now, Y we know, right? Strain is delta L by L. That also is given. And volume is A into L. So very easy. So half Y. Strain is delta L by L. And volume is A into L. So L gets cancelled. Right? Half Y. Y is 2 into 10 to the power 11. And this delta L will be squared, right? By L squared. So one more L will come here. Right? So we'll get 2 into 10 to the power 11. And delta L is squared. So delta L will be 0.1 into 10 to the power minus 3. This will get squared. Divide by length. Length is 2. And area is 1 millimeter square. 1 into 10 to the power minus 6. So this 2 and 2 will cancel. Here you have got 10 to the power 11. 10 to the power minus 4 minus 8. So this will become 10 to the power 3. So you get 10 to the power minus 3. 10 to the power minus 3, if you put that, you'll get 1 by 2 as 0.5. So 5 into 10 to the power minus 4 joules. So this is the work done. Right? Half stress into strain into volume gives us the work done. Work done per unit volume is half stress into strain. Half stress into strain into volume gives us the work done in this particular question. Now let us look at a problem where the energy stored in a rubber band is used to project a missile. So area of cross section is given as 1 mm square. The length of the rubber band is 10 centimeter. It is pulled by 2 centimeters, so delta L is 2 centimeter. Young's modulus is 5 into 10 to the power 8 Newton per meter square. And this energy that is stored in this case is used to project a missile of mass 5 grams. Right? So whatever energy stored in the rubber band, that goes to the missile as kinetic energy. So half mv squared will be equal to half stress into strain into volume. Energy stored in the rubber band is half stress into strain into volume. So half cancels. Mass is known. So V becomes root over stress into strain into volume divided by mass. Right? What is stress? Y into strain. So we get root over Y into strain square into volume by mass of that missile. So Y is 5 into 10 to the power 8. Strain is change in length by original length 2 by 10. So dividing, so no need to change units. And volume. Volume is area into length. Area is 10 to the power minus 6. Length is 10 centimeter, that is 0.1 meter. Divided by mass, which is 5 grams. So 5 into 10 to the power minus 3. So this will give us 10 to the power minus 7. So we'll get 10 here, right? 10, this will go up, it will become 10 to the power 4. And here 5 and 5 will cancel, so we'll get 4. 4 into 10 to the power 4. So what do you get? 10 to the power 4, 10 to the power 2 cancels at 400. Root over 400 is 20 meter per second. So that is the answer.